that in this decade, the probability for a quantum computer to crack Bitcoin's ECC protocol is very, very, very high. Quantum computing, the next generation of computing. Companies race to be the winner in this race, but I think there are many misconceptions that I want to share in this video. So what is quantum computing? A quantum computer is a computer that utilizes the quantum bit, or what we call qubits, which in itself is a really weird thing. At the quantum level, the state of a bit is uncertain, like a slot wheel. Okay, if you have played slot before, or have you seen a video of a slot machine before, only when inspected are the values collapsed into either a 0 or a 1, similar to pulling on the lever to see the result of the slot machine. So if we compare that to a regular computer, it is like you solving a question. You start with the known, then the ask, and then the solutions to the problem. Usually in computer case, it is by brute force. So you calculate it based on just brute forcing it through multiplication, addition, subtraction, or division. But in quantum computers, the answer is already there in the millions of combinations, and if there is a lot of qubits that randomly generated. We only need to find the correct one, or at least the most probable ones. So how do they do it? And I believe quantum computers to be like a wave in a wave. Okay, so I'm just analogizing it into a wave. When two waves collide with the same phase as each other, their amplitude, or the height of the wave, increases. But if the phase is 180 degrees away, then the wave will decrease or even cancel out depending on each of the wave's amplitude. So quantum computers works in the same way. The computer's algorithm is designed in a way that selects which one of the answers is the least likely to be correct and removes them, while the most likely to be correct based on the computer's algorithm is amplified. They will do this until only one answer has a very high probability, or near 100%, while the rest are essentially 0% probable. So does that mean quantum computers are faster? Well, not necessarily. Let's say you want to crack an 8-character password using a computer, a normal computer. You will need to brute force it by checking for each character and the millions of combinations it will bring. So that is how a classical computer do it. But a quantum computer performing the same task, that is checking the answer one by one, will actually be slower than a regular computer. And that is quite fascinating for me. And it turns out that the way quantum computers excel is through an algorithm called the Grover's algorithm. This algo makes it possible for quantum computers to shift through all the possible answers it contains. And I think it is something like, if a classical computer is counting from 1 to 1000, then a quantum computer is like a skimming a text containing numbers from 1 to 1000. Oh, obviously the skimming will be done faster than counting, right? And actually, if a standard computer needs n amount of steps, then the quantum computer only needs the square root of n. This meant that the more n increases, the more efficient quantum computers are, and vice versa. The less the n, the more less efficient quantum computers are. So by the innate nature of quantum computers, which is to contain every single combination of the variable that we are checking at a time, we can use skimming rather than calculating. So a real case is that for a standard computer to crack a 64-bit key, it needs on average an 18 quintillion tries or steps. That is 18 plus another 18 zeros at the back. For a quantum computer, only 4 billion. That is an order of magnitude, 9 orders magnitude away. So that is massive. So that means that on a small amount of data, and qubit size, it is not efficient to run a quantum computer which takes a lot of power and cooling with only marginal efficiency upgrades. But on a large random scale, like encryption, and etc., it is very, very insanely effective. So this is why quantum computing is a threat to anything digital or anything encrypted. Bitcoin and the internet runs on encryption to protect the data stored in them. And here is also the table I will post in editing of the most popular encryption standard used in the world and its susceptibility to a theoretically strong quantum computer. You can see that the internet and also the secure ones like SSL are vulnerable to quantum attacks. For Bitcoin, it is a tale of two halves. So on one hand, the mining side is very strong against quantum computers, meaning that there will be no noticeable benefit to running a quantum computer miner, or that is at least for now. This is because SHA-256, or the Bitcoin's mining algorithm, is really one of the most random encryption we have, since the numbers are meshed with different logic each time. Think of it as a blender to blend fruit, Let's say, theoretically, you can move each atoms of fruit puree, or the result of the fruit being blended, and reassemble it into a complete fruit again. But it is very, very hard because one, the particles is very small, and two, due to it bouncing around, moving here and there is no pattern that can be inferred. But Bitcoin has an Achilles heel, and that is the ECC protocol, or the elliptic curve cryptography. Now what is that? Well, first of all, ECC uses a 256-bit character, same as SHA-256, to store private keys. So essentially, the public key, which in Bitcoin case is your wallet address, is fed to this ECC protocol to generate your private key. So your private key is actually derived from your public key or your wallet address. Hold on, isn't the bit number the same as SHA-256? Why is one solved instantly while it still needs a lot of time for the other? That is because ECC uses a predictable algorithm that generates patterns. And quantum computers are insanely effective and efficient in recognizing and exploiting patterns. Think of ECC as a potato press as opposed to SHA-256's blender analogy. If you press a potato, in a potato press to make wedges in a press, the result usually has a pattern. And the chunks are large enough that it can kind of be able to reassemble easily. So it technically does not have close to infinite possibilities. So with sufficiently strong quantum computers, ECC will be instantly cracked like this, since the pattern is there and can be easily exploited by quantum computers. So essentially, it is similar to having your email and password almost the same for quantum computers. Only the letters change the order, and a normal person can just rearrange the characters, and voila, your account is hacked. So does this mean Bitcoin is under threat right now? Well, no, it's not. Fortunately, the current quantum computers still haven't been able to calculate patterns that well yet, and are prone to errors. To break ECC, they would need roughly 2,600 qubits that have almost zero errors. The current most advanced quantum computers, like IBM's Kukabura, has about 1,300 plus qubits with some errors. But this meant that in this decade, the probability for a quantum computer to crack Bitcoin's ECC protocol is very, very, very high. So how does Bitcoin effectively combat this fast-growing threat? Well, Bitcoin has already implemented one, that is the Taproot upgrade, which is, I would say, more of a stopgap measure. It essentially blocks access to your public keys by putting them again through the SHA-256. So essentially, a double encryption. First through an ECC and then through SHA-256. But it is not perfect because when you need to transact, you will broadcast your public key unencrypted by SHA-256, and that 10-minute block confirmation time is a vulnerability that can be exploited by quantum computers. Second, not all wallets support or migrate to Taproot in the first place, meaning a portion of Bitcoin's supply is still in danger and still uses only ECC encryption. Bitcoin as a whole is collectively moving to change the ECC protocol into a post-quantum cryptography encryption, with some key leaders such as the Falcon algorithm. The downside are that due to the increase in computation to calculate this encryption, the fees for transacting will be higher. The problem with BTC right now is that Satoshi Wallet is very unsecure, as it is using a wallet without any additional upgrade we use today. The solution could be to blacklist any Satoshi Wallet coins and treat it as a non-valid, but this raises another issue, and that is censorship. If a single BTC can be deemed not valid, what happens if that happens to the rest of the coins? It will be massively undermining BTC's original purpose of existing and might make BTC worthless. So to recap, BTC is vulnerable to quantum computers not because their mining algorithm is compromised, but their public-private key algorithm is. This makes quantum computers able to calculate your private keys instantly, making the encryption useless. BTC has already implemented a stopgap solution by rehashing or re-encrypting the public key through SHA-256. But there is a 10-minute vulnerability period, and some older wallets that haven't migrated to Taproot is also vulnerable to quantum attacks. BTC is actively working to change their ECC protocol into post-quantum ones, but it comes with either higher cost of transacting or a one-time use only encryption protocol, neither which is good for the users. So, as an investor to BTC, what should you do? I think the best way to protect yourself right now is to migrate your BTC to a Taproot capable wallet, especially if you have a legacy wallet. So if you have a wallet address that starts with 1 or 3, you are vulnerable. Also, even if your address starts with a BC character, you still should check if it's Taproot or it is just regular SegWit era wallet. Second, actively follow the news regarding the new encryption protocol. If you don't have enough time, then make sure to subscribe to my channel and I will do it for you, and I will post updates through this channel. And lastly, the third, avoid making constant transaction at least until the new protocol is rolled out. Although this video is more for Bitcoin investors, regular users of the internet are not safe either. It is probably time to change the encryption. If you like the content, check out this video about the 2025 crypto market I am putting right here. And I am Techie Power, and I wish you good luck and stay safe out there.